Okay, good morning.
Good morning, sir.
Good morning, sir.
All right, so we have in our last class, we finished the discussion on dynamic analysis, and today we will start a discussion on flywheels.
सर मिड सेम के लिए कुछ और प्रॉब्लम सॉल्व कर देते हैं ना रेफरेंस के लिए.
You mean to say solved examples?
Yes, sir. Some concepts are still needs practice. So just for reference, can we solve more questions for mid sem only?
Not today. I want to finish. I have two classes, so I want to finish flywheels. Every day I ask you if you have any issue. At that time, you have not raised anything. And still, if you have any issue, we can discuss, but it is in extra class. Okay.
Okay, sir, no problem.
So we have two classes today and day after tomorrow. So these two classes will discuss flywheels. Okay. Is it visible, this white screen?
Sir.
Yes, sir.
Yes, sir.
Discussing flywheels. Anybody has any idea about the flywheels? This is our lecture number 19. Any idea about flywheels? Have you studied flywheel in your engineering mechanics classes? Hello?
They can be said as mechanical batteries.
Yeah? Bolo?
They can be used to store energy in the form of kinetic energy.
Okay.
Store energy in form of conservation of angular
They help in maintaining inertia.
Some people say that they always wait in the lobby. I have allowed everyone they should not wait in the lobby. Why they say that they wait in the lobby? Because in this meeting there is the permission given to all. Anybody can enter. Yesterday I got some message from some student that he or she was unable to attend classes. And when he is saying that, the moment of submission of assignment. Okay, that is another discussion. Today we are discussing flywheels, and flywheels are mechanical objects which has mainly it has mass moment of inertia. And if you see the expression of kinetic energy, what is the expression for kinetic energy? What is the expression for kinetic energy? इंजीनियरिंग मैकेनिक्स में पढ़े हो ना? What is the expression for kinetic energy?
Sir, half I omega square plus half mv square.
Yep. Half I omega square I into omega square plus half mv square. So if we consider any object, mechanical object, which has some mass, that means it has some moment of inertia is there about some axis, about the axis about which the object is rotating. Say, let's say about this axis, the object is rotating, and about the same axis we have mass moment of inertia I, and you have mass m. At the same time, this object is also translating, then the total kinetic energy of this object is given by half I omega square, where omega is the angular velocity of this object, and where m is the mass of this object, and v is the rectilinear linear velocity of the object. Then the total kinetic energy of this object is given by this. Okay. But suppose the object is having pure rotation. It is having pure rotation. That means this quantity is no more there. So the kinetic energy can be written as, somebody is disturbing you. Please mute yourself. So that is, it is half I into omega square, where omega is the angular velocity. That means what? If suppose some object we is there, and basically if you have a regular object, if you have a regular object and that object is like a wheel, and that wheel, if you rotate it about some axis, if you rotate it about some axis, and it has some moment of inertia about this axis, then the depending on the rotational angular velocity, it will have some kinetic energy. And in many mechanical applications, this kinetic energy is useful. Where this kinetic energy is useful, let us take an example. Suppose you consider an IC engine. Have you started learning IC engines?
Yes, sir.
So in an IC engine, from the kinematic point of view, a very important mechanism is there used. What is that mechanism? To convert the gas pressure into rotational motion.
Slider
Rotation.
crank mechanism.
Slider crank mechanism. Suppose the gas pressure is acting here, and A is the cross-sectional area of the of the piston head, then this gas pressure is then converted to rotational uh, motion. Okay, so this is converted into rotational motion this way. And in our last discussions, like dynamic analysis of forces, there we have introduced one concept which was called equivalent, dynamically equivalent link. And we never used that dynamically equivalent link in our analysis. Since the syllabus is large, so I skip some of the things. This part, I am skipping this part, the analysis using the dynamically equivalent link. In actual case, the crank looks like this. It The crank looks like this, but when we analyze it in dynamics, we then have some equivalent link which looks like this link, which is a massless link, and the total mass of the crank is then concentrated at these two joints here and here. What is the advantage of that? Suppose the mass, part of the mass, this is m1. M1 mass is the equivalent mass due to this link, and here you have another mass, that is M2, and this M1 mass then added with the piston mass become the total mass of this reciprocating. Because you see, if you consider a point mass here, what is the motion of the point mass M1? The motion is along this length, okay, and the piston is also having this motion along this direction. That means it is only having a linear motion, okay, and it is easier to analyze those things. I am not going to those um, free body diagrams and discuss on what is the total force acting on it, but this is there, and in your future classes, in your syllabus, it is there in the design of mechanical systems. There you will study the turning moment and diagram, everything. So that is why I am keeping it short. So total mass here would be some this mass. Sometimes we represent it as total reciprocating mass. Okay, or this is sometimes referred to as MREC. Okay, and some mass is acting here. So what about this mass which is pointed concentrated here? That mass is only having a rotational motion, and this mass only having a translational motion. In actual case, the connecting rod is having a complicated motion combination of rotation and translation. But with this equivalent link, what we have, that the masses are having either only translational motion or rotational motion. That makes our analysis simpler, and, and that helps then. So this is rotating with, suppose, this angular velocity omega, but when it is rotating, it is creating some torque here. Okay, due to this forcing, some torque is available here, which can resist some loading. Okay, so this is your engine, which is providing a, suppose it is providing a torque. It is providing a torque M. Okay, at any instant it is providing a torque due to this gas pressure here, and that torque has to resist some load. So suppose this is automobile engine, then the road resistance will offer some resisting torque. Let's say that is what should I write the expressions? Some notations they use. Let me use that notation. Let's say this is M resistance, okay? And this is the M created by the engine, all right, due to this gas pressure. But when you see the gas pressure of a four-stroke engine, it is not constant, all right? Is it constant?
Yes,
in
sir.
your in your in a four-stroke engine? The crank is rotating. Eh? क्या बोल रहे हो? This
Sir,
angle,
it is not constant.
yeah, this angle is, let's say this angle is theta, which is called crank angle, which is rotating in this direction, and this theta, depending on this theta, the torque which is available is not constant. And typically, this torque looks like this. Typically, in a cycle, the torque looks like this. This is one cycle I have drawn, and the suppose this green line represents some average value of torque, some average value of torque. See, this is M, let's say this is average. And then this magenta line, purple line, this represents torque at any instant. And for a four-stroke engine, what is this total rotation? Total rotation, what is this total rotation?
4 pi.
This is 4 pi. Okay, and this is 2 revolutions, right? 4 pi means 2 revolutions of crank angle. Due to this 2 revolutions of crank angle, this you have, all right. Now think about your engine which is giving you a power or a torque which is fluctuating. Fluctuating is a fluctuating torque in a cycle. Okay, sometimes it is below average, sometimes it is above average, below average, then sometimes it is very high above average. Okay, if this kind of torque is available to you, and what will happen if you don't have any other arrangement, if you just connect your system with the four wheels, if you directly connect your system with four wheels, what will happen to your journey? कैसा लगेगा तुमको रास्ते में जाने के लिए? It will be jerky, right? There will be so many jerks, right? Sometimes it is not very comfortable for you, okay, this journey. Then you want to maintain, uh, so if you want to maintain a constant speed, what you need to do? If you want to maintain a constant speed, what you need to do? So if we think about from the angle of mechanics, this road is imposing some resistance, and in terms of torque, that resisting torque is, let's say, mr. Okay, this is the resisting torque on the crank, all right? And you have a available m is this, which is not even, which is fluctuating. But suppose we arrange something so that this mr is equivalent to that m average. Somehow, if it is always equal to m average, then what will happen? Then we will not feel any jerk, and it is almost smoothly this motion will go on. Okay, and how you can make that average? What is the way to make it this fluctuation? What is the way to make this fluctuation smoother? The way is, if we use this basic things about a wheel which is having some mass moment of inertia. So depending on this fluctuation, suppose I have not connected this wheels, these fluctuations are there. But when there is a very high amount of torque which is available here, that initially, suppose I connect with this wheel, okay, which is having a high mass moment of inertia. Then this total energy which is available here from this point to this point, which is available here, will be converted into the speed of this wheel. And since ideally there is no dissipation, that energy will be stored in this flywheel. Okay. Then when there is a when there is a case where the available torque is less than the average, at that time what will happen? This flywheel is having some energy which can provide or which can fill that gap. Okay, this is the way this flywheel can smoothen this availability of the torque into an average torque. Okay, so this kind of arrangement, if you have in the line this kind of arrangement, a flywheel in this line, then that flywheel will smoothen the availability of torque. Okay, so what actually is doing this flywheel in an automobile? In an automobile system, this flywheel is actually smoothening the availability of torque in a cycle. Okay. On the other hand, suppose this availability of the torque, okay, this availability of the torque, which is due to this flywheel, that becomes some average torque and smooth torque. But this average is suppose less than the required resistance. Then what will happen? What will happen to the speed of the vehicle?
It will reduce.
It will reduce. Okay. On the other hand, suppose this M average is greater than MR, then what will happen?
It will accelerate.
The speed will increase. In this case, the speed will decrease. When it is equivalent to MR, then the speed will be maintained. Okay. So, but what is the use of the flywheel in this case? Use of the flywheel is this uneven availability of torque to smoothen this in a cycle is the function of the flywheel. On the other hand, if you can have a you can have issue like this. Suppose the vehicle was running on the plane and then suddenly you have a slope like this and you have to travel through this. So what will happen? Actually, the resistance due to this slope is increased. In that case, this is the valid case, right? Your resistance is greater than whatever available torque. The speed will decrease. Then what you need to do to increase the speed? The availability of the torque has to be increased. Some mechanism which is developed which can sense this speed and then increase fuel supply, and then due to that fuel supply the M average increases. This system which sense the speed and can control the fuel supply of the engine, this is called governor. Why I am saying it here, to just give you the difference between these two mechanical components. One is called flywheel, another is called governor. Governor is a system, is a mechanism which senses the speed and controls the fuel in the system. On the other hand, suppose your vehicle is having motion and then you have a slope like this. In that case, what will happen? The resistance is less than the average, and again the governor will sense that, and that will change, that will reduce the fuel supply here, so that this m average always maintains this is equal or equivalent to this mr, and the speed versus fuel supply is always controlled. So that control is maintained through this mechanism governor. But what is the use of the flywheel? Flywheel smoothens the uh, availability of torque. Okay, so whatever fluctuation you have due to the gas pressure in the cylinder, that is smoothened by this flywheel. Okay, so with this, we have discussed the function of a flywheel. Now, for our further discussion, what we will do, we will now define few terms which are necessary for us. Okay, we will define maximum fluctuation of kinetic energy, coefficients of maximum fluctuation of kinetic energy in a cycle, and coefficient of fluctuation of speed. These are the few terms. Let us first define this with respect to some.
Yes, sir.
Huh,
So let's assume that there are four pistons in an engine,
yep,
and they'll all be in pi difference, phase difference with each other.
right.
So when one piston will be producing the the power stroke, then others is
Yes.
taking those energy from it. So
Right.
if we can use this arrangement, then this unevenness can be reduced, and
Yes.
plus the wheels also will act as flywheel once they get into motion. Like they have some omega, they will give that rotational energy to the engine if there is some evenness still remaining.
Yes, you are right. That that's the system which are in use in the automobile engines. Some of the engines are four cylinder, some of the engines are six cylinder. Okay, to just control this fluctuation. But then also, if we separate two suggestions, you have two suggestions. One is you want to use multi-cylinder engine, another is you want to use the wheels as your flywheel. Now,
Yes, sir.
if we discuss further, first suggestion, which you want to use multi-cylinder engine, yes, that are in use, but then also you need a flywheel, because if you use four number of cylinders, then also there will be a finite gap between your this gas pressure availability. Okay, there will be some still there will be some distance between these peaks. Okay, due to that the fluctuation will be there. To reduce that, again you need a flywheel. On the other hand, you have the second suggestion is your related to the use of this wheels as flywheel. uh, the whole thing, when the car is running, when the vehicle is running, it has some inertia. It also acts as a reservoir of energy, is it not?
Yes, sir.
When the vehicle is in motion, that is also having some energy. It it reserves some energy, and when you have a fluctuation, that energy makes up that. So as with the four wheels, they also do the same thing. But then suppose there is a case when you are taking a turn, so that time your wheels are not rotating in a same speed, but you have to then also you have to maintain the same, say, average or smooth availability of torque. So it is not a means you fix this part and then this part is separate. It is not like that. This whole thing is a system, and we are right now interested into the generation part only. Okay, when when the actual dynamics of the system is discussed, then the whole thing, everything, the wheels, the flywheel, the engine, torque availability, everything you have to consider. All right.
So, sir, using both these suggestions at the same time, a fair amount of smoothness can be achieved, but not
Yes.
complete.
Yes. So
Yeah, okay.
what I'm trying to say, that your suggestions here are fine. They are in use only. Okay. But then also you need a flywheel, because flywheel gives you the required smoothness. Okay. Just wheels cannot make that purpose. Why? As I said, when you are taking a turn, at that time your wheels are not rotating uh, at same
E-
speed. Okay.
Yeah.
Also, you have said that wheels are working like a reservoir of energy. At the same time, the whole car body is also working like reservoir of energy. Is it not?
Yes, sir.
Okay, coming back to our discussion, let us take some hypothetical case where the availability or torque looks like this. So as we have discussed, there could be multi-cylinder engine, then the availability of torque will have some graph which is not equals to this, and let's say that graph is like this. Okay, it is like this. And let us identify these points as A, B, C, D, E, like this. And in this direction, you have the torque. And now this is the availability of torque from a multi-cylinder engine. Okay. This is the average line, M average, and this is the availability of torque. Now, if I ask you, can you tell me what is the, suppose here the kinetic energy, available energy is, let's say, EA. Then what is the kinetic energy here at EB? If this is M, this is M, this is known to us, and this axis is theta. So everywhere you know this is theta A, this is theta B, and like that. So can you tell me about the kinetic energy available at, or the energy available at B? So what is the work done from this point to this point? What is the work done from this point to this point, from this point to this point? What is the work done? Generally work done M into d
Theta.
theta, है ना? And then
Yeah.
you have to integrate it over theta A to theta B. And since at theta A, you have the energy level, which is EA, that must be added. This is the total energy, right?
Yes, sir.
At
Yes,
B.
sir.
Similarly, for all the points, you can find out this energy, right? Now, tell me whether the energy at B is less than or greater than energy at A.
Greater than energy
Greater.
at A. Greater
According
than.
to this drawing, according to this this graph, we have the EB is greater than EA. Now, can you say something about the energy between EB and EC?
EC is less than EB.
EC is less than EB. Now it is understood that since this is an integration, from this point to this point, everything is subtracted. From this point to this point, everything energy is added, then again subtracted, then again added. Then one thing you see that, can we say something about the minimum and maximum energy level? Minimum and maximum energy. So it's a kinetic energy. Look at this, our discussion. From here, we can see one thing, that this maximum and minimum energy will be this crossing point. No?
Yes, sir.
Okay. So if we say that what is the fluctuation, maximum fluctuation of kinetic energy? What is the maximum fluctuation of kinetic energy? Generally, this is written as delta Ke maximum. What is this? So suppose somewhere in between the theta 1 angle is related to minimum speed. Speed and kinetic energy are equivalent, right? Where the kinetic energy, because this, you see where the kinetic energy is maximum, speed is maximum. Where the kinetic energy is minimum, speed is minimum, right? From the point of view of flywheel. Okay. So theta 1, which is a minimum speed, and let's say theta 2 is related to maximum speed. Then what is the maximum fluctuation of kinetic energy? When theta 1, the energy level is minimum. When angle is theta 2, energy level is maximum. Then what is the maximum fluctuation of kinetic energy? It should be
Theta 2
the
minus
energy
theta 1.
between theta 1 to theta 2, right? M minus mr. Why we are doing so? M minus mr. M is the available energy and mr is the resisting torque. And that multiplied with d theta gives you the maximum kinetic energy. Okay. So now we define next term, which is called coefficient of maximum. Maximum fluctuation of don't worry, these are just definitions. Okay, this is defined as maximum fluctuation of kinetic energy divided by total energy in a cycle. So this is in a cycle. Suppose with this completes, this is a complete cycle. This is a complete cycle. Okay, in this cycle, it should be from point A to A. So not, that is not correct. Let's go little further. Okay, up to this point. Let's say this is F, and then again this point is A. So here we started from this point and it ends here. Okay, this whole thing is a cycle. Up to this point is one cycle. Okay. So in this one cycle, you have a minimum speed, you have a maximum speed, and then the difference between the torque at that time, the average torque which is available, and the resisting torque, the difference that gives you the maximum fluctuation of kinetic energy. Okay, and basically this we are representing as M here. This M is M minus MR. You can write down M d theta. I mean, if we say that this M is M average, okay, then in one cycle, what is the total energy in one cycle? Total energy in one cycle. That is the cyclic integral M into the total angle, okay, M d theta, and this goes from maybe for a four-stroke engine, this is 0 to 4 pi. Okay, and now we define another term which is called coefficient of fluctuation of speed. And this term is defined as K is equals to maximum speed minus minimum speed divided by omega average. Okay. Generally, not always, generally this omega average is maximum plus minimum by 2. Okay. So for a system, suppose this maximum fluctuation of kinetic energy and the average speed, these two quantities are, let's say, given. And the problem is here in this part of this discussion, we have to determine the mass moment of inertia of the required flywheel, mass moment of inertia of the flywheel, that we need to determine. What is given for a system, you cannot go beyond this maximum fluctuation of kinetic energy. There will be always some given value. That means that is a design consideration, that you cannot go beyond a particular fluctuation. And the average speed, that is again design consideration. So this average speed has to be maintained, and this fluctuation of kinetic energy has to be maintained. And to maintain these two things, design a flywheel. That is the problem we are going to solve here. Okay, so still now, as we have discussed that what is the torque, definition of torque? If we say that M minus MR at any instant, the available torque is this, and the resisting torque is this, then this is the balance torque, and this balance torque must be stored in the flywheel. If it is stored, that means the flywheel is having some angular acceleration. Suppose the mass moment of inertia of the flywheel is J, then let us call it J. Okay, mass moment of inertia J. So J into alpha is the equation where alpha is the angular acceleration of the flywheel. We know the torque is to I into alpha, moment of inertia into acceleration, angular acceleration. Okay, so this is valid at any instant. Now let us do this for the interval theta 1 to theta 2. So what is the total available energy? And this must be on the other side also. We'll do this integration J alpha d theta. Okay, when we do that, you see what is the definition, left hand side, what it is. This is the maximum fluctuation of kinetic energy, the left hand side. So we'll write Ke fluctuation maximum, and that is equals to, in the right hand side we have, what is the definition of alpha? Alpha equals to d omega dt. This can be written as d omega d theta dt. So this is omega into d omega d theta, right? If we substitute it here, j omega d omega d theta. So you can now see that this is theta 1 and theta 2. You can now see that this is j omega into d omega. And theta 1 corresponds to omega 1, theta 2 corresponds to omega 2, the maximum speed, minimum speed and maximum speed. So we can also write here, this is minimum speed and this is maximum speed. Okay, we have started this. Theta 1 corresponds to minimum speed, theta 2 corresponds to maximum speed. So since the variable here is omega, we have now written this. So if you do the integration, what you will have here, J is a constant and you will have half into omega square, right?
Yes, sir.
And the limits are omega minimum to omega maximum. That means the maximum fluctuation of kinetic energy is equals to half into J. Now let's do this omega. So this is omega maximum square minus omega minimum square, and you have half J. This can be written like this. This can be written like this. You see, we can write down omega maximum, omega max plus omega mean divided by 2 multiplied with omega max minus omega mean, right? We can do like this. So the kinetic energy, maximum fluctuation of kinetic energy is What is this according to our definition?
Omega
This
average.
definition, omega average. Okay. Yeah. So this is J into omega average multiplied with uh, J into omega average multiplied with omega maximum minus omega minimum. Let's do a little bit of algebra. Purposefully, we multiply the denominator and numerator with omega average. Okay, when you do that, then you can see that this is J into omega average square multiplied with Ks. Ks is the maximum fluctuation of, sorry, coefficient of fluctuation of speed, which is omega maximum minus omega minimum by omega average. Okay, the difference, the total fluctuation of speed by average speed, that is the coefficient of fluctuation of speed. We use that here, and we have it. Now we have a relation like this, and finally, from this relation, if we just want to find out what is this mass moment of inertia of the flywheel, then this is Ke maximum divided by omega average square into Ks. So for a given data, if you have this data, maximum fluctuation of kinetic energy and the average speed which has to be maintained, and then the maximum fluctuation of coefficient of fluctuation of speed, these few things are known to us, then we can design a flywheel. We can design a flywheel which mass moment of inertia is this. Once the mass moment of inertia is this, you know, for a disk, what is the mass moment of inertia formula for a disk?
mr square by 2.
M square by 2.
mr square by 2. So I mean, then you can decide among this m and r square, which has to be equals to j. If the value of j is known to you, then you can decide what should be the mass, what should be the radius, so that you cannot always, this is again, you have to choose that this multiplication must be equals to j. Okay. You cannot take a very high radius and very small mass, and other way is also true. You cannot take a very uh, lengthy flywheel of very less diameter. That also cannot be done. So there are always limitation of space. There are always limitation of bearing system, everything. Okay, depending on that, you have to choose these two things so that finally you can arrive at this j, which will serve the purpose. We have 4 minutes left, and can I discuss one example? Okay, let me discuss it tomorrow. Tomorrow we will discuss two examples, and that's the end of this discussion. Okay, let me discuss another thing. And this is a flywheel. The case of flywheel we discuss required for a automobile system, for a IC engine. This is required for this particular type of application. we can have another type of application. So for example, you take an punching press. Any idea about punching press? किसी को कोई idea है? Any idea about punching press? Suppose there is a object, maybe made up of some material, and you want to make a hole, through hole. You want to make a through hole, and that is done by a machine which has a punch here. Okay, and that punch comes and hits on the object and make this hole. And this is that means, and these materials are flowing on a shop. Some arrangement is there. In each cycle, this makes this machine. Suppose there is a machine. That machine makes one punch. Okay, and uh, a hole is made there. So every cycle of this operation of this machine, it is making a hole. But that making hole takes a very small part or a part of the total cycle. That means if there is a, suppose there is a slider crank mechanism which is doing this, and that mechanism, the crank is rotating from this point and this is rotating like this. So suppose the punching takes place from this point to this point, this throughout this time, the punching taking place. That means the energy required to punch, the energy required to make a hole is during this time only. Rest of the time, it is free. There is no absorption of energy. So this is again, suppose your machine is operated through a motor, and through a motor, the machine is operated through a motor, and then that motor is a constant torque motor. It is supplying constant energy, constant power, but that power is utilized uh, for a for a part of the cycle, not for the whole revolution. For a part of the cycle, it is the power is utilized. Then then again you have a fluctuation of utilization of energy. In that case also, you can use a flywheel so that rest of the time the flywheel will store energy, and for this time the flywheel, the energy will be used from the flywheel. This is another application of flywheel. In our next class, we will discuss two examples to understand uh, these two applications. One is for this IC engine, another is for punching press. In one case, the availability of the torque is fluctuating, but the resisting torque is constant. In another case, the resisting torque is fluctuating, but the available torque is constant. Both the cases, the flywheel gives you a smooth operation. Okay. If you have any question, we can discuss now.
So in punching press example,
Hmm.
after giving energy to the flywheel, can the motor be shut down for some time, or is it constantly working?
No, motor is constantly working. That you cannot do. You, uh, that you cannot do. You cannot switch it on and switch it off the motor. What is the problem? Switch it on and off the motor for the use. See, understand the operation. Mm, it needs a particular speed. When it is punching, it needs a particular speed. Suppose you switch it on. So the motor takes some time to reach to that speed, right? So this on and off will not work. On the other hand, you can say that we can solve this problem using some other technique. Now you can use a solenoid and do that thing. Then that is another issue. That is the issue of designing. We are using here a motor to have those punches. Okay, these similar kind of examples you can see here and there. Now, sometimes you will see that people are establishing a pole using some hammer. Okay, there is a mechanical hammer. That hammer um, puts some hits on the pole and it goes into the ground. So this heating is again the heating time, that is a small duration. Whole cycle there is no operation, and or if you heat through again just by gravity, then against the gravity you have to pull the hammer. So during the pulling the hammer, the energy is used, and then when it is coming due to the action of gravity, that time the energy has no use. Then also you need a flywheel for smooth operation. Okay, so these are the cases, few cases where the flywheel can be used, and generally which will be useful is this relation. Basically, the relation which we are using is this: the kinetic energy is equals to I into omega square. That is the basic principle, and that basic principle. Another thing we have used here, you see the same thing. Here we have used this, the unbalanced torque is actually increasing the acceleration. Unbalanced torque means there is some acceleration. And using this, we come to this formula, okay, which gives us the moment of inertia. All right, if you have any more question, you can ask me, or if you have particular problems related to the previous topics which I have discussed, you can gather those topics and we can have extra class only for them who feels that they want to have some clarity. All right, if no more
Sir,
question is there, yeah, please.
सर आपने जो लास्ट असाइनमेंट दिया था सर,
Yes,
वो सर सिंगल क्वेश्चन बनाने में लगभग 45 मिनट या आधा घंटा के आसपास लग जाता है, तो
कौन
सर
सा
ऐसा
क्वेश्चन, कौन सा क्वेश्चन मुझे याद नहीं है एक्चुअली। क्वेश्चन
सर प्रैक्टिस प्रॉब्लम 4 उसका थर्ड क्वेश्चन था।
yes, practice problem for third question. Now I remember the
Yes, so the first part of the question is easy, sir, but the second part is not easy, sir. In that case, we have to find the velocity and then acceleration, and then we have to draw force diagram on
yeah,
joints.
that is a two problem. One is the kinematic analysis problem, another is dynamic analysis problem.
Yes, sir.
Okay, that consists of two problems. A kinematic analysis is a separate problem. Dynamic analysis is a separate problem. Sometimes the kinematic quantities are given. So, so when I will give you a question, I will take care that how much time it should take, and depending on that, the marks will be distributed.
Yes, sir. Yes, sir. Thank you, sir.
Okay. No, that I will take care. If I am also a human being, I can make mistake, but I will take care of that. how much time it should take, and depending on that, I'll give you the distribution of marks.
Yes.
That is how I make questions. Okay. Don't worry about exams. I know many people means 95% people. My last 3 years of online exam experience, 93, 95, 98% people just copy. One solution is available, and I don't know, one person who has not solved it properly. There are so many mistakes, and then people copy. Okay. And most interesting thing is somebody has written X, and that become, after copying, that becomes a pi. That kind of examination and is going on, and you guys are much more serious about these grades. Is it the, tell me about this. I give you a question and you write exam. In the exam, all of you copy from some source. From some source you have copied. And what is the use of the grade which I am giving to you, or the all other faculties give you the grade? You have a grade card. What is the use of that grade card? Is it saying that how good you are in copying? वो भी नहीं बता सकता है वो ग्रेड कार्ड. तो मैं कहने का मतलब ये है कि ग्रेड कार्ड का कोई मतलब नहीं है. कुछ सीख लो, काम में आएगा. ठीक है. ग्रेड कार्ड का ऑब्वियसली मतलब है. सिनेरियो देख रहे हो, एक्चुअल सिनेरियो ये है. इसमें ग्रेड कार्ड का क्या मतलब? कोई मतलब नहीं है. I don't want to demoralize you guys. Score good marks. That is useful. And let's see you. Let's meet on Wednesday. Thank you for your attention.
Thank you.